So in the last video we have been discussing about the convergence of series, right? So if you haven't watched the previous video, that is part 1, that is around 1 hour 40 minutes video. So if you haven't watched that video, please watch that video, because in the previous video we have solved 14 problems based on comparison test, right? So we are discussing the topic convergence of series. We can expect a 10 mark question from real analysis from this topic, right? So we can expect 60 to 70% that there will be one question from convergence of series. So there are many tests to test whether the given series is convergent or divergent. The first test we are discussing is comparison test. So in comparison test, I have given the test statement, and then we have solved 14 problems in the previous video. So what the states is, if un is a given series, now you find another series bn from un, right? And you find limit n tends to infinity un by vn, and if it is finite and non-zero, then both un and vn converge or diverge together. If one is convergent, another is also convergent. If one is divergent, another is also divergent. So both behave alike. This is the result that we this is test that we I gave in the previous video, right? So if you haven't watched that video, please watch that video. If you have watched that video only, this video will be more clear for you. Now we have solved 14 problems in the previous video. Now we'll continue 15th problem. So yes, so we'll solve 15th problem now. So discuss the convergence of the series. Discuss the convergence of a series. So 15th problem, right? So the previous video we have a 14th problem. 15th problem is, so summation n is equal to 1 to infinity root n square plus 1 minus root n cube, right? So we need to check whether the series is given, whether the series is convergent or divergent. So you can see this problem is different from the 14th problem that we solved earlier, right? So whenever you have a series like this, right? So whenever a numerator is of the form, let us say a minus b or a plus b, you always do rationalize, right? Rationalize means you have to take conjugate, right? So I'll give you one hint. So when the numerator is of the form a minus b or a plus b, so here a minus b, right? So in this pattern or a plus b pattern, so you always recommended to rationalize this term. That is, we need to take conjugate, right? So let us take un to be equal to square root of n square plus 1 minus square root of n cube. Now just rationalize this. For rationalize, what you have to do is you need to multiply and divide by a conjugate. So here the conjugate is root n square plus 1 plus root n cube divided by root n square plus 1 plus root n cube. So after rationalizing, now you can follow the pattern that we did for the first 14 problems. So when you multiply this, you will have square root of, now you can see this is of the form a minus b, a plus b. So it will be a square minus b square. So a square minus b square will be, root will be cancelled. So we are only left with n square plus 1 minus n cube, right? N square plus 1 whole square minus n cube whole square. Now you can see a minus b, a plus b. So it will be a square minus b square. So a square will be root n square plus 1 whole square. Sorry, root n square plus 1 whole square. The square will get cancelled. The square and root will get cancelled. And here again root n cube whole square. So again root will get cancelled. So we have only n cube. And denominator we will have square root of n square plus 1 plus root n cube, right? Yes. So now you can follow the previous method that we did for the first 14 problem. Now you simplify this. Now you find bn from un, and you find limit n tends to infinity un by vn, and if it is finite and non-zero, then both the series behave alike. So we just simplify this. So here you will have, so this is nothing but n square plus 1 minus n cube divided by, and here what I'm going to do is I'm going to take n cube common, right? I'm going to take n cube common. I will take root n cube common, right? So if I take root n cube common, this term will be 1, this term will be 1, and here I am taking root n cube common. Say here we have only n square, so we will have 1 by n, sorry, square root of 1 by n plus 1 by n cube, right? So we will have square root of 1 by n plus 1 by n cube. So if I take n cube common, or else what I will do is we will simplify this to some more extent. What I will do is, let me write this term as n cube plus 1 by n, n cube plus n by 1. So what I have did is I have multiplied and divided by n. So since we have to take highest power common in the denominator, so since highest power is n cube, here we don't have n cube, right? So I am making a term to be equal to n cube here. So this is nothing but n square plus 1 minus n cube divided by this will be square root of if I take n cube common now, so we will have 1 by n. Now if I take n cube common, we will have 1 plus 1 by n square plus square root of n cube, right? Now I'm going to take root n cube common. So if I take root n cube common, we will have n square plus 1 minus n cube divided by, so if I take root n cube common, what we will have? Here we will have 1 by n. Here we will have square root of 1 by n plus actually I made some mistake, I think. Sorry, yes, that's what I made mistake. Okay, the question is n cube, right? It is n cube, sorry. N cube, right? Now it will be easy for us to take the common terms. N square, sorry, it is n cube. Now this will be n square plus 1 minus n cube divided by, now you can see I can take n cube common. So if I take root n cube common, here we will have root n cube common, here we will have square root of 1 plus 1 by n cube plus 1, right? So I taken root n cube common, so we will have 1 plus 1 by n cube, and here we will have only 1. Now what we will do is again this also n cube, right? So this two will get cancelled, so we have 1 by square root of n cube into square root of 1 plus 1 by n cube plus 1. Now you take bn to be equal to 1 by root n cube, right? This is the one that did in the previous video. Now you find limit n tends to infinity un by bn, limit n tends to infinity un by bn. So this is nothing but limit n tends to infinity. So what is our un? Un is the, you can take this term straight away because this term is simplification of this term. So we will take this straight away, root n cube into square root of 1 plus 1 by n cube plus 1 divided by, and what is bn? Bn is 1 by square root of n cube. So this two will get cancelled. So as n tends to infinity, this term will tends to 0. So we will have square root of 1 plus 1. So square root of 1 is 1. So which will be 1 by 2. Right? This will be 1 by 2, which is finite and non-zero. So by comparison test, both un and bn behave alike. Both un and bn behave alike. So since summation bn, so what is summation bn? 1 by square root of n power 3 by 2, right? So we will have a n cube root which is something n power 3 by 2 is convergent. Why? Is convergent because we know that summation 1 by n power p is convergent if p is strictly greater than 1. So here we have p is equal to 3 by 2, which is strictly greater than 1. So therefore the series Vn is convergent. So this implies summation Un is also convergent. So therefore the given series is convergent, right? So both Un and Vn behave alike. So now I will move on to the next problem. So this is 15th problem. I will move on to 16th problem. Yes. Sixteenth problem is square root of summation square root of n power 4 plus 1 minus n square. So again you can see this is of the form a minus b or a plus b, and we can do first to just take b and un to be equal to square root of n power 4 plus 1 minus n square, n power 4 plus 1 minus n square. Now again it is rationalized. For that I need to take the conjugate. So here the conjugate is square root of n power 4 plus 1 plus square root of n square and square root of n power 4 plus 1, sorry, not square root, plus n square. Now again you can see this is of the form a minus b a plus b. So this will be a minus b a plus b, which is a square minus b square. So this will be square root of n power 4 plus 1 whole square minus n square whole square divided by square root of n power 4 plus 1 plus n square, and this will get cancelled. So we have n power 4 plus 1 minus n power 4 divided by square root of, now if we take n power 4 common here, we will have 1 plus 1 by n power 4 plus n square. So this two will get cancelled. So we have 1 by, now I can take n square common here, because if n power 4 becomes outside, it will be n square. So this will be, if we take n square common, this term will be 1 plus 1 by n power 4 plus 1, right? So here if you bring this term outside, here we will have n square. So if we take n square common, the root of 1 plus 1 by n power 4 plus 1. Now you take bn to be equal to, now take bn to be equal to 1 by n square, 1 by n square. Now what about limit n tends to infinity un by vn? You have to take vn by taking the highest power in the denominator, and always choose vn to be in the form 1 by n power p, 1 by n power p. So this will be limit n tends to infinity, and un is 1 by n square, 1 by n square into root 1 plus 1 by n power 4 plus 1 divided by 1 by n square. So this 2 will get cancelled. So as n tends to infinity, this tends to 0. So again you will have 1 by 2, which is finite and non-zero. So therefore by comparison test, both un and vn behave alike. So since vn is convergent, why vn is convergent, summation vn is convergent? Because summation 1 by, we have taken vn to be equal to 1 by n square, and this is convergent because this summation 1 by n power p is convergent if p is strictly greater than 1. So here we have p is equal to 2, so therefore this is convergent. So this is convergent. This means summation un is also convergent because both the series behave alike. So if one is convergent, another is also convergent. So we move on to the next problem, which is 17th problem. So 17th problem is summation square root of n square plus 1 minus square root of n square minus 1, right? So we need to check whether this series is convergent or divergent. So let us take un to be equal to square root of n square plus 1 minus square root of n square minus 1. Now again we just rationalize. So for rationalize I need to divide this by n square plus 1 plus square root of n square minus 1, square root of n square plus 1 minus square root plus square root of n square minus 1. So this will be a minus b, a plus b, so it will be a square minus b square. So root will get cancelled, so we have n square plus 1 minus n square minus 1 divided by square root of n square plus 1 plus square root of n square minus 1. This 2 will get cancelled, so we have this will be 2, so 2 divided by, now again I can take n common here, right? Because I can take n square common here. If I bring that to outside of the root, it will be n alone. So if I take n common here, you will have, this will be square root of 1 plus 1 by n square. Or you can also, if you have any confusion, what you do is you just take n square common here. So we'll have 1 plus 1 by n square plus again you just take n square common here inside the root. So we'll have 1 minus 1 by n square. Now you take this n square and this n square out. This will be n, here it will be n. So we take n common here. We take n common here. So this will be square root of 1 plus 1 by n square plus square root of 1 minus 1 by n square. Now if we take n square outside, it will be n, again it will be n, and if we take n common here, this term will come. Now you take bn to be 1 by n. Now we take bn to be equal to 1 by n. You can take any bn, or else you can also take 2 by n, no problem. Now you find limit n tends to infinity un by bn. This will be limit n tends to infinity. Now if you find un by bn, you will have, so un is 2 by n into square root of 1 plus 1 by n square plus square root of 1 minus 1 by n square divided by 1 by n. So this 1 by n and this 1 by n will get cancelled. So as n tends to infinity, this term tends to 0, this term tends to 0. So we will have square root of 1 plus 0 plus square root of 1 plus 0. So this will be 1, this will be 1. So 1 plus 1 is 2, 2 by 2 is 1. So this entire term will be 1, which is finite and non-zero. So therefore both un and bn behave alike. So since what is summation bn, which is summation 1 by n, which is divergent. Why? Summation 1 by n power p is convergent if and only if p is greater than 1. But here p is equal to 1, therefore the series is divergent. So since summation bn is divergent, so therefore the given series un is also divergent.